I'm Moses. I'm the co-founder and CEO of ClearML. We open sourced about 3 years ago. We are probably the only full end-to-end open source solution in MLOps. Yeah? To get COVID. That's what you're saying. Get the COVID. I will get the COVID. Okay. So we open sourced 3 years ago. We're probably the only one that is actually end-to-end MLOps solution that is open source, including the backend. You can run everything yourselves. Today, I'll talk about data management. Okay, so what is data versioning? This is what I have. This is a screenshot of my desktop, I think, or someone else's, but it's basically the same. Which one of you guys is working for academia? None. Okay, so not faking papers. Okay, which one of you is faking models for their boss? No? Half. Okay, so this is important. Basically, the bottom line is when we want to make the model look better, this is carving out data. So when we carve out data, the only thing that we need to remember is where was the original, because at the end, we will need to get it to production, but beforehand, we just want the nice graphs. So this entire talk is about making sure that you end up with a really nice model and a graph, but then making sure that we can trace back where the original data is, so we don't end up actually messing up the production and making everyone happy so they can sell the model to whomever. And then we just buy ourselves another maybe 6 months, a year of time to actually get things working, which is basically the gist here. Versioning and lineage. Yeah, so I think that most of us are here. Most days I'm here. Half of the days when I realize that I don't, I'm the first one. And yeah, this is definitely me, or this morning. So the idea is, again, at least we know, it's not that we're saying that you should have good data. I mean, we are optimistic, but not that optimistic. And the idea is that when we do have some data, we can create nice data from it. And when I say nice, I mean it works with our model. That's our aim. We're not here to solve every problem in the world. Accessibility, yes. So this is important. The idea is that delegation is what we need. We want our minions to run our code. And so for our minions to run our code, we need to make sure that they have access to the data that our code is actually training with. And in order to do that, we somehow need to make sure that they have actual access to the data. So not that I'm against S3 buckets or Azure blobs or GCP or whatever you're using, but the email thread with the right bucket and then trying to look for the right bucket in the email thread because we had tens of them, that's probably not very good. So the idea is that at least we have some catalog of where we ended up putting all our data. So when we tell our minions, hey, run our model against this data, I think it's very good and the results will be fantastic, then they can basically just right-click something and get it done. ClearML-Data. So ClearML-Data is a solution to basically do just that. It's an open source solution. Basically, it is a file-based data management solution. So basically, you think like, let's zip everything that we have and upload it to a bucket and just make sure that someone will get it for us and unzip it and cache it. And that's about it. But then we realized that we don't change most of the files from a version to a version. We kind of delete half of them, maybe replace the other half. So we decided to add differentiable storage. So basically every version will store the delta from the previous version. So think Git, but not Git. Like no one does merges actually with data. I mean, you can, but who would know what you'll end up with? So you can do actual merges with ClearML-Data, but it's rolling the dice. No one actually knows what you'll end up with, and you'll have to basically verify. But it supports it because why not? It's free. And it's bundled with the experiment management, which basically means that when you're using the data in your experiment, you actually automatically get a link to the actual data that you were using, which is nice because now your model is actually linked with the data that it was trained with. Okay, this is how it looks like. We see the version tree. Basically, this is a very simple one. We will probably not end up with hundreds of versions, but it's not really limited. It depends on, well, how many times you'll try to end up with a working data set. Working was defined before. And every version will actually link to the previous version. So you might have like multiple versions and you might end up with merging trees, etc. But they are standalone. So at the end, we can always select a specific version and use that. And the idea is that when we actually use them, they're cached. So if I'm downloading a parent version of a data set, I'm actually downloading the data of the delta. I probably already had the parent version locally. That means that if we're spinning instances actually using them, we're not re-downloading the entire data set every time. Every version, so obviously we have the metadata with some version numbers that we can control and metadata and names and tags and whatnot, but we can also add statistics. So this is nice. This means that when we generate the data set itself, we can attach some insights to the type of data that we have. This is not automatically. Someone actually generated that. This is obviously tied with a type of data that you're storing. So it can be like statistics over your table with some annotations, or maybe some samples of your actual data. So this is not the entire data set. Basically, the idea here is to get some insight to the actual data that we stored in the dataset version. So how do we actually do that? Basically, you have two options. One is CLI. That's relatively simple. You create a data set, you add some files, and you finish it, which means we upload everything to your storage solution, whatever you configure the system with. It can be your S3 bucket, Azure, even a shared folder, if you will, which means it's nice. I can always access it. And it also means that it's not hard coded. So if tomorrow I want to switch to another cloud provider, as long as I reconfigure it, everything just works. So we close it, we upload, we have our new data set. So how do we actually get the data? So the idea is your code actually fetches the data. So instead of you guys having like a bash script before you run your code, let's get the data set, unzip it, put it in a folder, have that folder hard coded into the training session or evaluation or whatnot. This is actually tied with the code itself. So now your code is now fully abstracted. So you can have like an ID or a name or whatever we have there. What do we have there? We have a project name and a dataset name. Okay, so we'll have the project name and a dataset name as parameters for our code. And then we can have the code itself fetch the data. And we'll end up with basically a folder where we can actually look through all the data files. So basically glob over the files themselves. But the idea is that itself is it's part of the code. And again, this is fully cached. So if you run the same code twice, we don't end up unzipping or downloading the same files again and again. And the second thing is we can now have those arguments as part of the arguments for our training or evaluation code, right? Because basically we abstracted the entire thing. And this is fully contained inside the code base itself. No need to add some bash scripts, etc. Yes, that's connected with our actual training or evaluation. So basically what we have here is how do we actually make sure that we can trace back everything? So when we're running the code itself, it's not that we don't want the code to actually access the data. We want that a month later, we understand which model was trained on which specific data. And then in theory, we could retrain the model on maybe a new version of the data or a bad version of the data or a blind data set so that we can actually test the model performance itself. So that's kind of the idea. And the idea is that we also don't want that process to be manual. So we want as much automagic as possible so we don't have to add a lot of boilerplate code to everything that we do. I'm assuming that this is what we'll end up with. Some graphs on accuracy over time and something that I cannot read, loss. Yes, it's loss over time. We can see the data set itself here. So we have a name for the data set and an ID. So that ID, you can think of the ID as kind of a commit hash ID. It's a unique ID for the data set and the version. throughout the entire system. That means that if we later rerun the code with a different ID, we can override it. So if we want to run the same code base with a different version of the data set, even if it comes from a different data set, it's fully supported. So that's kind of the idea of this unique ID. Think of it as a commit ID that you don't have to add the branch to it if you want to compare it into like cloning a Git repository. And obviously we have the alias for that data set or how we use it inside the code itself. So things like training and validation, both data sets that we need in training an actual model. The first one, anyone is actually doing that? Yes, one. Okay. Not a very good statistics. Yeah, that's what you should probably do. In reality, it's very hard. Trying to actually create a single source of truth in a constantly changing data world is very, very challenging. The ideas of actually introducing data management into the system is actually making that feasible without a data management solution, which means like a catalog where you can actually tag something as this is probably what we're using. It's basically making sure that everyone complies to the same bucket or something and no one has access rights to it, which will break very quickly. Who does a second? Who does any pre-processing through their data? Okay, no one. Some, you do some. Okay, can you reproduce it? Most of the time. Let's say 90% of the time. Let's be optimistic. Yeah, this is important because usually the pre-processing code actually changes with the data. Like we realize that we made a mistake or we want to filter out more data or labels were incorrect. We should probably store that as well. This is why combining the data set with the experiment management is important, because this is our way to combine the pre-processing code base with whatever it contains with the data creation itself. This means that we can reproduce it later. We can basically trace back how we created that specific version, etc. Who actually abstracts data from their model or evaluation? Meaning you have a single variable that you can change to train or evaluate a model on a totally new data set. No way. 1, 2, 3. This is it? 4. Okay. Yeah. How do you guys do that? Like, do you just SSH to a machine and run the entire thing from scratch? Just nod. No? Okay. This is basically, okay. So the idea is if you combine the two, obviously, ClearML does orchestration and covers that as well. There is a reason it's there, but the idea is that if you have an orchestration solution and you abstract the data, that means that you can run your code on a totally new data with only a single parameter that will change that. Even if it's just a path to an S3 bucket, that's better than doing it yourselves and then obviously forgetting a step in the middle and then realizing your model does not converge a day later and probably a $500 day later as well. Okay, tag data set. Who does that? How do you do that? Don't say Git. Don't say Git. Yeah, this is just good practice when you actually have something that is working. Just so for other people to know which version to work with. So when you do actually have like versioning solution of whatever, no one knows which version is the best one. Assuming the latest is the best is obviously not right. It's like working on master and assuming that it will not break. So it's basically the same with data. So assuming that we actually had everything up until now, which obviously we don't, but let's assume that we did. The next step is actually slicing your data, not in code. So I'll start with a quick question. Who actually does that in code? Like decides on how they want to train their data in code? Like not, yes. Nice. This is more than expected. this probably creates the best results in terms of ROI, like return on time spent, is actually trying to understand which data did not work with the model, fit it more, or carve out the data that was just bad. But the idea is to actually extract it from the code itself. So it should be someone else's problem to try the combination of different data slicing and the effect it has on the model itself, because it's time consuming and you can get minions to do that. And in the end, it's just a graph that you can end up watching a week later and say, oh yeah, you're right. We should not use the whatever we had there. It was mislabeled or whatnot. So the idea is to actually add that into the data itself. And in order to do that, we need to push our data into a database so we can actually query and slice the data itself. So that's the first step, which is not very intuitive, I have to admit. Then we have to manage queries. So again, just so we later know which query produced whatever. And the last one is basically make sure that someone will feed the right data for us. So think of it as, well, that's basically what database does. And the rest are nice to have, like statistics and exploration, etc. So you know what to do. If it all works out, you'll end up with something like that, which is kind of a preview of the data that you have and the ability to slice it based on specific attributes, which I'm not sure what they are. I am told that they are cheap and expensive. Is this cheap? No. And appetizing and not appetizing. This is very subjective. Not sure what model you end up with. Maybe it's a personal model. Okay, but the gist is that you have better understanding, and now you can train a personal model based on your preference, or whatever preference they added into the data set itself. And then you can have some combination of. And if you're really fancy, you can actually do some oversampling as well. So if the data is not balanced, and most data isn't, at least when we fit it into the network itself, we'll have about the same number of instances per class or per object or per whatever we're training. And we can also sit in a table, apparently, because some of the data is not very visual. So imagine like maybe like NLP or a combination where actually seeing the thumbnails does not provide a lot of information, and you might have like metadata on top of it. So a nice way to browse things, but basically it's just a way to create the query so someone else can run your model instead of you, so you can build the next version or go to the beach or whatever. And this is how you should store the query itself, I assume, which is probably a fancy version of a configuration file, because at the end, every query is a configuration file at the end of the day.